How's it going, everybody? Cody Pravat here, coming at you today with a video about lighting in terms of machine vision and especially vision inspection. Lighting can play a very important and a very key role when it comes to vision inspection and making sure you get the best accuracy possible. It can also play a very big role when it comes to reading codes as well. You still want to make sure you have good lighting there because it's going to affect how accurate you can read those codes, how well you can see them, whether or not you have too much reflectance coming back, whether or not the ambient light's throwing you off. All this ties together in machine vision. Lighting is probably the most crucial part of all of this. So today I'm going to have a bunch of different objects that's going to come through here, and I'm going to be using a monochrome Insight 2000 sensor with an integrated white light. In some instances, I'm going to change out the cover for a polarized cover. Going to put on a polarized filter as well, since all that can be integrated. And then I'm actually going to use external lighting with a sensor today, which ordinarily you wouldn't do, but I'm going to use that to get the point across. So we're going to have a blue dome light, a red bar light, a blue ring light, and then a UV light that's going to be at around a 395 wavelength. Right now we're starting off with 4 markers in the center here, and this is actually just ambient light. I have the integrated light is not turned on. I just have the exposure turned up to just get the image through. The problem with ambient light, however, is it's going to cast reflectance, which you'll also see in the ring light. And it's also going to cause problems when it comes to the consistency of the lighting. So if you're in a factory or facility manufacturing or shipping something out and you use just ambient light, you're going to find where that light changes throughout the day, especially if you have fluorescent lights around the area, especially if you have windows in where the sun's coming in, or forklifts driving by, or people walking by casting shadows. Ambient light is going to throw you off. So there's a lot of situations where the ambient light looks great, but it's not always going to look great, and it's really going to mess your inspections up a lot. So we want to cast everything out with external light and filters if we have the ability to as well. So here we just have an integrated white light, the ring light on the Insight sensor. And you can see it casts a little more even illumination across this, however we're still getting this glare. So to solve that, we would just throw some polarizing covers or a filter on there to kind of get all that out of there, or angle the light differently. However, on all this, we're not really inspecting whether or not markers are a certain size. We're not really counting them. We just want to see if there's, say, a red or a blue marker in these groupings. So the only way to really do that, we can obviously tell that this is a little bit of a different shade. This is slightly lighter as well, and these two seem pretty black. The only way to do that is to throw on the light that's the same color, or filter that's the same color of what you're trying to look for. Because it's only going to take in that red light or the blue light or the green light, what have you, coming through there, and everything's going to look white with that same color. So if we throw a red bar light on here, the red is going to pop out and look white because we have so much red reflecting back at us. If we were to throw a red filter on here as well, it's probably going to pop out a little bit more and look a little more white, but we're still looking pretty good there. And then if we were looking for the blue marker per se, we would just throw the blue ring light on there, and this blue would pop out. And again, if we throw a blue filter on there, that's going to look a little bit better. You can also see the difference between a red bar light without any type of diffused cover on it to cast the illumination a little even, and the ring light. So the ring light is going to kind of light the whole picture up, and it's also going to change the direction of these shadows here. See, the red light, there wasn't too much shadowing, but our corners are a little bit dark here. We're even here, but we still got the shadows. We're getting the blue to pop out there. So here we have another red light thrown into the image. We actually have a Chick-fil-A sauce packet. All the lettering on this packet is red. So if you were to zoom in on this a little more, you can still see the lettering is there because there's not just pure red ink in here. It's got some other stuff in there as well. So you can still see that there is lettering there, but it's going to give you better access to just inspecting this packet, making sure these edges are, say, uniform, or that there's not like a gash in it or a hole in it or a rip in there. It's going to give you the ability to inspect this without having to worry about all the noise. So if we were to look here, we've actually got a polarized cover on this, which is why it's a little darker, and everything looks black. So if we wanted to inspect to see if there was a hole there or a gash, it's going to be a little more difficult because all this is going to be throwing us off. And again, here we've got a black smiley face and a red smiley face. Let's say these two emblems are exactly the same, and you want to make sure there weren't two printed on here. And let's say you have a problem with one emblem that's a different color that's supposed to be going on a different product printing on the one that's supposed to be red. To do that, again, we throw a red light on there and we see that now everything's whited out here except for this black emblem. So if we didn't want that to be on there, we could just throw a pattern tool on here, invert these results. That's going to be bad. So the next one, we have a polarized cover on this block of wood here. It's basically just a channel cut out and a screw is going to be going through here. We're just trying to make sure that everything is supposed to be here. Maybe we want to measure these edges. Maybe you want to make sure that this hole cut out isn't so close to the edge here. We're gonna need to have good lighting. If we're looking for edges, we're gonna need the best lighting possible. So here we throw in a red bar light, and we can see that we're getting better illumination. We still have some thick shadows right here that we'd want to be a little better. We don't have the contrast exactly that we want, but it still looks a whole lot better than our original image. We'd probably still be able to inspect off this if we had a better background. We throw a blue ring light on there. We're getting a little more even illumination, so our shadowing's a little better. And we also change the angle up a little bit on this to where it's not looking so much down. It's kind of more over and at a different angle. And we are getting a lot more even illumination at the top where we want to inspect here. So this is going to give us better contrast. You can see the white to black here, the white to black here, white to black here, and then you can see here the edges are a good size, so that's going to let us measure those a little more accurate. So here we just have a sardine can. It's pretty reflective. Right now there's no polarizing cover on this at all, so you see we're getting a lot of bounce back here. We're actually looking directly overhead at this image. So if you wanted to inspect anything on this, it's going to prove a little difficult with this lighting here. We throw on a polarized cover, it's going to make the image a little darker. However, it's going to take a lot of this glare out, but not all of the glare. So the only way to really solve that would be to angle this. Angle this. Actually, we have taken the polarized cover off, and it's going to, basically the light's not bouncing straight back at us. The light's sort of bouncing this way. And it's going to give us availability to inspect this without having to worry about that white light bouncing. So here we actually have like a bottle or a can, and our customer is wanting to look to make sure that this lettering is where it needs to be, or if this lettering is there at all. They're not really trying to read it, they just want to make sure that it's there. And if it's cut off, they want to make sure that it's not completely cut off. They have different colored bottles and different ink. Their inside sensor is working perfectly with all the other bottles. However, when it comes to the silver bottle with the yellow lettering, the integrated white light isn't doing well. So instead of buying another sensor with different lighting on it, we could actually just throw on an external light and have it come on when the silver bottles are running that day. So this is with a red light. You can see the red light's making it pop a little more. However, it's not exactly the contrast we would want it to be. We throw on a blue ring light, and this is popping out a lot more. So if we were to angle this ring light in a different way, say looking from the bottom up, we would cast a little more even luminance on this bevel here. So here's another picture with the blue light, just cast it a little bit differently on everything. And then if we throw on a UV light, so this is a pretty big bar light, so it's going to kind of cast light across the whole picture, and we pop out a little bit, I don't know, better per se, but the lighting is a little stronger and it's at a different angle, so it kind of makes it pop out a little more. However, we'd still want to kind of clean the edges up on this bevel here. So this image here, we actually have a block of wood, and it's got a UV mark on it, or an orange mark on it that has UV paint in it. So it's supposed to add some pretty good reflectance to this. However, with just the integrated light, we can't see this at all. And the customer just wants to make sure that that UV mark is there. They don't want to read anything, they don't want to inspect it. They just want to make sure a UV mark is on this board. So this is the piece of wood with a blue ring light, or blue dome light one, and you're still not seeing that UV mark pop out. So this is actually with a red bar light here. And the funny thing about the red bar light on this was with my eye, it was popping out extremely bright. It was reflecting off the wood very well. However, when you look on the sensor, nothing's popping out. You can hardly see the line there. And now this is with the UV light with a decent exposure on it. You can see it popping out here, but it's not exactly what we want because we're catching all this white here. We could probably still tell that it was there with a vision system. With a sensor, it's not going to do so well. This is with a dark red filter on it here. This is actually with a polarized filter on it here. So you can see how different filtering, even if it's not a UV filter, can make these pop out. So if you don't have access to a UV filter, you're not completely lost.
If you have, say, dark red or polarized filter, you can still make this stuff pop out a little bit better. Also, keep in mind this is a 395 wavelength UV light, and that's going to be what's called a near UV or UVA. You still have UVB, which is a middle, and a UVC, which is far. So the far is anywhere from 180 to 280 nanometers. The middle is anywhere from 280 to 315, and then the near is going to go all the way from 315 to 400. So with these different UV lights, you're also going to make your objects pop out a little differently. So we may find that this actually does a little better with a middle or a far or UVB or UVC light. It may pop out a little more. We may be able to put a UV filter on there. And then you'll also find that some UV ink isn't that affected by one wavelength, and that the other one it's very bright and one it's extremely dark. So here we have the dark red filter put on this again at a very low exposure. Now we really can't see much in this image. We can tell there's that white line there, but our customer just wants to make sure that this UV mark is on a board or that it's on a package, whatever. They just want to make sure the UV mark's there. They don't want to inspect it. Now with machine vision, since we have this white mark and everything else is black, it doesn't really care if it can barely see it. It still knows it's there. So since we have the ability to adjust what pixels we're actually looking for, we can make this a little brighter. If we want to have anything else thrown out, we can just slightly adjust this here. So we're still picking up everything. Even when the UV mark changes, the lighting changes at different parts of the field of view, we're still picking this up. So here again we have the Chick-fil-A sauce packet, and we are going to be using different types of lighting to just show you how everything can be affected. So this is just an integrated white ring light on the inside sensor. If we're wanting to inspect this lettering or this lettering, we're just going to make sure that this group of text is there. So with the inside sensor we can't really read this, but we can at least make sure that this is there, or that there is an emblem up here, or that there's a certain density up here, and we're not missing sauce, It's going to make it a little more difficult with the integrated ring light shining directly on this. So if we had to be straight overhead, so we couldn't angle it at all, we had to be right overhead to inspect this going down a line, it's going to be a little difficult with an integrated light. However, if we throw a blue ring light on there, it's going to make this a little more even. You're going to have less light bouncing back at you because the light's sort of going around, and the way these ring lights are set up is it's actually sort of angled in instead of being so directly down. We throw a blue dome light on there, everything's going to look a little more even. Since no light is directly hitting this, it's actually just bouncing off of something else and just casting light in this area. It's going to look a lot better. You're going to have less shadows on everything and a lot darker on your reds here. So that's going to give us the availability to inspect this in a better way. So as you can see, different lighting, whether it be at different angles or straight overhead, is going to affect the way that you can inspect different objects. Some cases, a integrated ring light may not be best if it has to be overhead. Sometimes you might want to put a polarized cover on there, and even in most cases when you have a polarized cover, you're still getting a little reflectance back. Say you want to inspect an object like this packet here that's got a lot of edges and valleys in it, a dome light or a ring light might work best. However, usually if you have to use this external lighting, it's going to be in a case to where you would need a vision system as opposed to a vision sensor. However, in some cases, if you have a vision sensor online, you can still throw some external lighting in there if your application changes up a little bit and you don't want to go changing around sensors or systems within your facility. So that's just some basics on some of the lighting. This just gives you a good overview of what to expect with different types of lighting and different types of environment. If you have any questions, send me an email or contact Air Hydropower.